So this exam style question begins by having us look at an interaction between a negative kaon, a proton, which creates a positive kaon, a neutral kaon, and some particle x. So that equation shows the interaction between a proton and a negative kaon that results in the formation of particle x. They'd like us to state and explain whether x is a charged particle. So how do we do that? Well, we know that charge is always conserved. So what we do is we simply look at the charge in this equation and see what that leaves x to be. So we see that the charge on a negative kaon is -1, charge on a proton is +1, so the total charge on the left-hand side is 0. On the right-hand side, this positive kaon has a charge of +1, this neutral kaon has a charge of 0, and we have to decide what the charge on the particle x is. Well, we need that to balance so that it's also equal to 0, so that means that the x must have a charge of -1. So we see this tells us that x is negatively charged, else charge is not conserved. And that gets us our 2 marks. 1 mark for correctly identifying its charge, and the next for saying whether it's charged or not, and the next for saying that charge is not conserved if that's not the case. So moving on, we need to state and explain whether x is a lepton, baryon, or meson. The very first thing we're going to do is simply look at the baryon number. Because we see we've got a proton on this side, all of these mesons have a baryon number of 0, so that's going to be very straightforward. We see that the meson, the K-, has a baryon number of 0, the proton, baryon number of +1, the K+ has a baryon number of 0, the K0, baryon number of 0, because they're both mesons, so we're left wondering what the x is. Well, we see that for this to balance, it must have a baryon number of +1 as well. And so with that, we can answer our question. So our answer here is that x must be a baryon, or else baryon number is not conserved. Now for the second mark, first mark is just for identifying whether it's a baryon, lepton, or meson, getting that correct. The next mark you could have got simply by stating this, x must be a baryon, or else baryon number is not conserved, or x must be a baryon to conserve baryon number, something like that. Or you could have shown what we did above, a balanced equation by actually writing in the -1 or the +1 for each of these as necessary to show that the equation balanced too. But actually just writing the sentence was enough, so we went with that. The next thing we need to do is just state the quark structure of the K-, the K+, and the K0. For this is unfortunately just something we need to know, and we can know that by knowing the properties of K- and working it out. For instance, we know that the K- is negatively charged, strangeness of -1, and we can just work that out by what we know about quarks, etc. But to be honest, we literally just did that, so let's just go back to what we just found. And we found for our mesons, we found that our K- was a strange anti-up, our K+ was an up anti-strange, and finally for our K0, we know that actually there's 2 of them there, and they were happy with either answer. Now they wouldn't want you to give both, obviously, you just had to pick one, but the key thing is the next part of the question worked regardless of which one you picked. You would have got a different answer to somebody else who'd used the opposite one, but the answer was about how you did it rather than about the actual, because this is just some unknown particle, there wasn't a correct answer here. As long as you picked one of these, you would get a right answer. So we'll go through and we'll do both, basically, just in case you practice this question and got a different answer.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.